Hello and welcome back. Today we'll be doing question 2 from the 2003 maths paper. Let's get started. Question 2. Let k and n be positive integers such that n is greater than or equal to 2k and n minus 2 all factorial over n minus 2k all factorial is equal to k factorial 2 to the k minus 1. Recall that for r greater than or equal to 1, r factorial is the product r multiplied by r minus 1, r minus 2, all the way to 2 times 1, and that 0 factorial is defined to be equal to 1. Part 1. Suppose that k is equal to 1. What are the possible values of n? Part 2. Suppose that k is equal to 2. Show that n minus 2, n minus 3 is equal to 4. What are the possible values of n? Part 3. Suppose that k is equal to 3. Show that it is impossible that n is greater than or equal to 7. Part 4. Suppose that k is greater than or equal to 4. Show that there are no possible values of n. Pause the video to have a think, and once you're ready, restart to see if you were correct. Let's get started with part 1. Firstly, we'll substitute k equals 1 into the left-hand side and the right-hand side, and this gives us that n minus 2 all factorial all over n minus 2 all factorial is equal to 1, and this holds for all n greater than or equal to 2. We can also look at part 2. Substituting in 2 gives n minus 2 all factorial over n minus 4 all factorial is equal to 4, and this means that n minus 2, n minus 3, n minus 4 all the way to 1, all over n minus 4, n minus 5, all the way to 1 is equal to 4, and thus cancelling terms, this gives n minus 2, n minus 3 is equal to 4. Solving this equation gives two solutions of n. However, these solutions are not integers, and therefore there are no solutions for n. Now we can move on to part 3. Firstly, we'll write down n minus 2 all factorial over n minus 6 all factorial, and this gives n minus 2, n minus 3, n minus 4, n minus 5 is equal to 24. Now we'll notice that if n is greater than or equal to 7, then n minus 2 all factorial over n minus 6 all factorial is greater than or equal to 120, which is greater than 24. Since the left-hand side fraction increases as n increases, we can see this from the polynomial form, we have that n greater than or equal to 7 is impossible. Finally, we'll move on to part 4. In the case where k is greater than or equal to 4, n minus 2 all factorial over n minus 2k all factorial is a product of 2k minus 2, which is guaranteed to be greater than 6 consecutive integers, and each of which is at least 2. Thus, this left-hand side fraction is greater than or equal to the factorial of 2k minus 2. However, for k greater than or equal to 4, 2k minus 2 all factorial is strictly greater than k factorial 2 to the k minus 1. This can be determined by comparing growth rates and base case values. The growth rate of a factorial of 2k is going to be greater than the factorial of k multiplied by some exponential, and in the base case where k is equal to 4, the factorial of 2k minus 2 is 6 factorial, which is 720, and this is much larger than 4 factorial multiplied by 2 to the 3, which is 192. Thus, we can determine that there is no n for k greater than or equal to 4. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.